Alright, so I'm going to start my video here on how to use the Desmos worksheet that I created to compare different levels of interest rates, not just interest rates, but types of interest as well. First thing I'm going to do is show that the worksheet can be reached by clicking a link that can be shared with anyone rather than just accessed by me, because I have an account and built it. So what we have here is a worksheet that's going to compare three types of interest: simple interest, compound interest, and continuous compounding interest. On the left we have the input bar, and you can see I have written up notes for those who are using this to explain what's going on. Each of my three folders contains the formula that I have typed in, and that is graphed on the right hand side, along with an explanation of the names and all of the inputs or variables that are used. I did have to cheat a bit and call this a simple, and then down here I was able to put simple as a subscript, but please understand that is there because future amounts formulas are always written as A of t, where t is time. So I wanted to make it obvious that these are all future amount formulas, but then indicate that with each of the subscripts. So A simple, A compound, and A continuous. So what's interesting about this is these formulas always are written in terms of time, but as you can see, in our simple interest formula, we have three inputs. We have the principal, the rate, and the time. With our compound interest, we have four inputs. We have principal, interest rate, we have lowercase n here, which is the number of compounds per year, and then t is time. And then in continuous compounding, we only have three variables here: the principal, the interest rate, and time. E is a constant. E is just a number that we use in math. So what I wanted to do is, instead of just being able to manipulate time, what I wanted to do is actually be able to manipulate principal, interest rate, and compounds per year. So you can see each graph, the red line represents the future amount that would be gained using simple interest calculation. The black line shows compound interest, and then the blue line shows continuous compounding. My first bar is P. I've set my limits to lowest value that you can plug in for P is 1. The greatest is 1,000. The steps are 1. You can always come in here and type a different value. You can also press play, and you can see how our graph is changed by different values of the principal. What's going on here? You'll see that the distance between the graphs is changing a little bit, but they're staying generally the same. What's changing is our principal, and the principal is really just our y-intercept. Is where did we start at time 0? How much money did we have invested? All right, so that's where, so this is the thing that moves. All three come from that. The next variable is the interest rate. So the interest rate, bring this back down to a smaller number. Interest rate, the higher the interest rate, the better the return. So as interest rates increase, all three curves change. All three are moving so that they get higher faster. In other words, it takes less time to gain more money. So the higher the interest, the steeper and steeper each one gets. Interest is a decimal, so it only makes sense between 0 and 1. So again, I've limited my R value to that. But again, you can type over that with anything you want. And then lastly are the compounds. Number of compounds per year. This only impacts the compound interest formula, which is the black line. So as I compound more and more often, so when n is 1, this means I compound once a year. When n is 2, I compound twice a year. And you can see it doesn't take many compounds. This black line is going to start to get closer and closer and closer, and it's going to mimic the continuous compounding line. The idea here is that if I just continuously compound, if I compound every possible second, what I'm going to end up with is the blue line. So 1 compound a year versus 12 compounds a year, which is what you would typically see in a bank account. This is what you're going to see with savings accounts, checking accounts to draw interest. You're going to see once, you're going to see a compound once a month. So this can manipulate and move around, but that black line is going to move closer and closer to the blue. So I can zoom in and out. My window only makes sense when time is positive and when future amount is positive as well. So I'm only dealing with this top right quadrant, which is why I've selected the window to appear here. And so now that we have all these 3 inputs, which we don't normally get to see how they manipulate, we have the one that we're used to seeing, which is time. So this last folder has future amount in W years. Time is typically in T, but I'd create a new variable here, W, just because of the way Desmos is set up, because I wanted to have of this variable W, and I wanted to be able to manipulate it with a slider. So you'll notice as I move W, my curves stop moving. They don't move like they did for P, R, and N. The reason for that is these values of P, R, and N are already taken into account, and what I have left, if when I take all 3 of those into account, what I have left is time. So I still have a variable, which means my output is a graph. Now I'm plugging in a number for that variable. So instead of changing my graphs, what I'm doing is I'm looking at when W is 2 and time is 2. What does my simple interest return? What does my compound interest return? And what does my continuous interest return? The difference between them after 1 compound or after 1 year, it's very, very small. The original so right now my original principal is $10. Interest rate's 9%, wish we could get that. And the difference between the 3 is very small, $10.90, $10.92, $10.94. But let time continue. We move time, and I have my steps here at 1, so that each tick, it actually tries to fall on each tick. And we can see after 20 years, I started with $10 simple interest. I would only have 28. Compound interest, I've got 58. And then with continuous compounding, I'd have 60. Again, the manipulators above, the sliders above, if I move N, remember N only impacts my compound interest output. So as I move that, we can see our future value moving live as you make that manipulation. So this is a great tool to show students how and I'm just going to scroll back up and show you the equations just as a reminder. Here are my 3 equations. It's supposed to be in terms of just time, but I really have 4 variables or 4 inputs here: the principal, the rate, the number of compounds, and time. So I hope this is enjoyable. I would like to share this. This will be shared with other other instructors, and this can be passed along to their math classes. Recreating a Desmos file like this is not something I would want to do a step-by-step process for. This is something that if you're in the field, if you're in this discipline, I think it's doable. You could take what I've done and easily copy and paste, but this is, anytime you're talking about simple interest, compound interest, and continuous compounding, this worksheet would work. So this crosses more than just my basic Math 143 class and continues over to any class that uses it. All right, so if you have any questions about this, please let me know. I hope this works, and thank you.